Section 3.2, parallel lines and transversals. So in this section, we've got 4 theorems that we're dealing with. If you know these theorems and you know how they work, particularly the vocab associated, then turns into a fairly enjoyable section usually. So the first word, corresponding angles theorem, says if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. So, 2 lines that are parallel, and this line going through it that crosses them, the transversal, 1, 2, 3, 4, 5, 6, 7, 8. I changed the order of my numbering. I went kind of around in a big circle. 1, 2, 3, 4, 5, 6, 7, 8. The corresponding angle theorem says that corresponding angles are congruent. So which angle corresponds to angle 1? 7. They're both in the top left. So this says that angle 1 is congruent to angle 7. Which one corresponds to angle 2? Is 4. It says angle 2 is congruent to angle 4. It says angle 3 is congruent to angle 5. And it says angle 6 and angle 8 are also congruent. Corresponding angles theorem says corresponding angles are congruent as long as the lines are parallel. Alternate interior angle theorem. If 2 parallel lines are cut by a transversal, then guess what? The alternate interior angles are congruent. We have lots of things here that are congruent. Alternate interior, 3 and 7. So this one says angle 3 is congruent to angle 7, 4, and 8. Angle 4 is congruent to angle 8. Alternate exterior angle. If 2 parallel lines are cut by a transversal, then the alternate exterior angles are congruent. Alternate 1, 2, 5, 6. Sorry, exterior 1, 2, 5, 6. Alternate 1 and 5. Angle 1 is congruent to angle 5, and 2 is congruent to 6. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Congruent, 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 all the way down. Consecutive interior angles are different. So, consecutive interior says if the lines are parallel, then the consecutive interior angles are supplementary. So what that means is that 3 and 4, angle 3 and angle 4 add to 180, and angle 8 and angle 7 add to 180. Corresponding are congruent. Alternate interior are congruent. Alternate exterior are congruent. Consecutive interior are not congruent. They add to 180. Now there are 2 more that I want to put down here just as a reminder. Vertical angles. Are they congruent or do they add to 180? Vertical angles are congruent. Linear pair are supplementary. They add to 180. So you're either going to be setting things equal, or adding them to equal 180. If in doubt, set them equal, because out of these 6 situations, 4 of them are where you set them congruent. 2 of them are where you equal them to 180, but better than just guessing with the odds, no. All 4 of them are where you set them equal. Consecutive interior and linear pairs are where you equal them to 180. Now these 4 must be parallel. For them to be true, parallel, 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 parallel. Your lines must be parallel. These 2 down here are always true. We don't even need 2 lines to have vertical angles. We don't even need 2 lines to have a linear pair. They certainly don't have to be parallel. These are always true. These 4, your lines must be parallel. So let's look at what we've got. Example 1. Find the measure of each angle. Justify your answer with a theorem. So lots of ways to go about this. If you don't necessarily like the way I do it, that's fine. Go a different route. Lots of ways to do it. So what I see first is that the lines are parallel. That means all of these rules up here will work. So let's look at our picture. The 2 parallel lines, this is the interior between the 2 lines. And let's just start with angle 1. Angle 1 has what relationship to this 110 degrees? Now, why am I using the 110? I'm using that one, quite honestly, because it's the only number in the picture. I don't know what other number you would start with because there aren't any. So, angle 1 and the 110, are they corresponding, alternate interior, alternate exterior, or consecutive? Well, look where they are. They are both interior. So, which of these allow both to be inside? Well, that's alternate interior or consecutive interior. Corresponding is going to have, say, 1 exterior and 1 interior. If you have one of each, you're probably dealing with corresponding. These are both interior, and if you look, they're on opposite sides of the transversal. These are alternate interior angles, and the alternate interior angle theorem says alternate interior angles are congruent. So the measure of angle 1 is 110 degrees by the alternate interior angle theorem. By AIA theorem. Angle 1 is alternate interior to 110. All right, now look at 2 and 110. 110 is interior. What about angle 2? That is exterior. So what we said, the only one that allows 1 interior and 1 exterior is corresponding, usually. Vertical and linear also do, but probably corresponding here. Let's check. The 110 is kind of like on the bottom, maybe the bottom right of this group, and the 2 is the bottom right. Angle 2 and the 110 are corresponding. And what does the corresponding angles theorem says? That corresponding angles are congruent, which means the measure of angle 2 is also 110 degrees by the corresponding angle theorem. Now, for me, I use corresponding angles theorem because that's what I'm trying to teach you in this section. I absolutely would not have actually used corresponding angle theorem if I was doing the problem. I would have said, look, angle 1 and angle 2, totally ignore this part of the picture. Look at angle 1 and angle 2. They are across from each other in this x, which means they are vertical angles. I would have said that angle 2 was 110 degrees by the vertical angle theorem. Quite honestly, I might not have even done angle 1 first. I might have done angle 2 first by corresponding angle, and then found angle 1 by vertical angles. There are lots of ways to solve this problem. You should be using theorems because the lines are parallel. Example 2, find the measure of each angle, justify your answer with a theorem. So let's see here. Here's the interior. Here's the 63. Let's do angle 1 first. 63 and angle 1. Which one are they? Are they corresponding, alternate interior, alternate exterior, consecutive, vertical angles, or linear pair? 63 is inside, 1 is outside, 63 is kind of on the bottom right, 1 is on the bottom right. They're corresponding. The corresponding angles theorem says corresponding angles are congruent, which means the measure of angle 1 is 63 degrees by the corresponding angle theorem. What about angle 2? Here's the 63. Here is the 2. What is their relationship? These are both on the inside. They're both interior, both inside the parallel lines. So are they alternate interior or consecutive interior or just a linear pair? Remember, a linear pair is when they're making a Y. These, they don't really make a Y. They make more like this shape. That's not a Y. They are not alternate because they're both on the right side of the transversal. 63 and angle 2 are consecutive interior angles, and that means they add up to 180. So the measure of angle 2 plus 63 equals 180. You can subtract 63 from both sides, and the measure of angle 2 is equal to 117 by the consecutive interior angle theorem. Now again, I found them this way because of the vocab words we're practicing. I absolutely would not have done that if I was solving this problem for myself. I would have found angle 1 first, and then I actually would have seen this. I would have completely ignored this, that half, and I would have looked at this. Do you see that Y? 1 and 2 are a linear pair. They make a line. There's the Y. And because they make a line, they would add up to 180. Now the math part of it would look the same, and you'll get the same answer. The difference will be your justification here, which is why it's really important for you to somehow, in your picture, mark what you're looking at. You saw me circle the 63 and the 1, and then I boxed in the 63 and the 2 to help you see what I was connecting. If I was doing linear pair, I would be absolutely darkening that Y. Let's keep going. Example 3. Find the value of x show your steps and justify your answer. So the lines are parallel, so we can use all of the rules. And we have the 110, and we have the x plus 12. Now I understand the x plus 12 has parentheses around it. That's just a technicality. As we actually go to do the problem, those parentheses aren't needed. So what relationship do these two have? Here's the inside, the interior. Let's write it this way. That's the interior. So the 110 and the x plus 12 are on the exterior, and they are alternate because this one is below the transversal and this one is above. So these are alternate exterior angles, and according to alternate exterior angles, they are congruent, which means these are equal. So what you can do is set them equal. X plus 12 equals 110 by the alternate exterior angle theorem. And then you can solve using algebra. Remember, what you do to one side, you have to do to the other. X equals 98. Example 4, find the value of x, show your steps, and justify your answer. So here, 10x minus 55 and the 45. They are inside, they are interior of the parallel lines, and the 10x minus 55 is on the right side of the transversal, the 45 is on the left. These are alternate interior angles. According to the alternate interior angles theorem, the angles are congruent. That means their measures are equal, so we can set 10x minus 55 equal to 45 by the alternate interior angle theorem. And now use algebra to solve. What you do to one side, you must do to the other. So add 55 to both sides, and you get 10x equals 100. Then divide both sides by 10, and x equals 10. Now I understand, as I'm saying things like add 55 to both sides, technically, in order to get the answer, you may not have to say those things. You may not have to actually show that step. Many of you are very, very good at algebra. You can just kind of solve it. With a calculator, you pick it up, you type a bunch of stuff in, you get the answer. But it's important to show the work, and it's important to practice the language. It's actually called mathematical literacy, the ability to read and write in math. And that's necessary. It'll be necessary for your final exam to be showing those things and explaining what you do. So example 5, find the value of x, show your steps, and justify your answer. Now here, we have 52 degrees, we have 4x degrees, and then we have this little awkward 6 here. Notice it does not have a degree symbol, which means it is not, that's not a measurement. It's just a name. Just like up here, I labeled 1, 2, 3, 4, 5, 6, 7, 8. They just labeled it with a 6, probably because, I don't know, it came off of another picture or something. It's to kind of help you with a stepping stone in the middle, I think. So, 4x and 52. Here's the interior, which means both of those are exterior. The 4x is exterior and the 52 is exterior. Are they alternate exterior? Well, the 4x is above the line, above the transversal, and the 52 is above the transversal. So they are not alternate exterior. In fact, there's no vocab word to describe the 4x and the 52 together. So what that means is that we can't go directly from the 4x to the 52. So instead, let's look at the 52 and maybe the 6. What are they? What's the relationship between the 52 and the 6? One's inside and one's outside. They're both above the transversal, like in the top right corner. They are corresponding, which means the measure of angle 6 is equal to 52 degrees by the corresponding angle theorem. 52, 52. So this is now 52 degrees. But we still don't have the x as part of our problem, so now we look at this part here. Do you see it? A line with a y. The 4x and the 52 are a linear pair, which means the 4x plus the 52 is equal to 180 by the linear pair postulate. And we can solve. Subtract 52 from both sides. 4x is equal to 128. Divide both sides by 4. X equals 32. Last example, find the value of x, show your steps, and justify your answer. So let's see here again. The 2x minus 3 is outside. The 153 is inside, but they're not corresponding. So we're going to have to use this angle 2 in the middle somehow. So let's see here. Here's the interior angles. The 153 and the 2. Look, they're both inside and they're both on the right side of the transversal. They are consecutive interior angles. They add to 180. So the measure of angle 2 plus 153 equals 180 by the consecutive interior angle theorem. Notice the lines are parallel, so it's a theorem. And solve. The measure of angle 2 is 27. So this one here is 27 degrees. Now the second part has to do with the 2x minus 3 and angle 2. Look at where they are. For this part, we don't even need the bottom part of the picture. It has nothing to do with the second line. We have two lines at the top. Here and here. On opposite sides of those x's, of that x, those are vertical angles, opposite sides of the x, which means they're equal by the vertical angle theorem. So set them equal. 2x minus 3 is equal to 27. By the vertical angles theorem. Solve. Add 3 to both sides. 2x is equal to 30. Divide both sides by 2. And x equals 15. Pay particular attention to the vocab. Practice if you have a different way of solving, but you're still using these theorems, you're probably okay. But if you don't have to follow the same path as I do, but if you are following different paths, it might be worth stopping by office hours sometime and verifying that the path you're taking is an acceptable path. You should now be able to go ahead and complete your homework for section 3.2.